Introduction to AWS Direct Connect. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today we are diving deep into AWS Direct Connect, which is one of the most important networking services that Amazon Web Services offers for enterprise customers. Direct Connect is fundamentally different from the standard way most people connect to AWS, which is over the public internet. Instead of relying on the unpredictable nature of internet connectivity, Direct Connect provides you with a dedicated, private network connection between your on-premises data center or office and AWS. Think of it like this. When you use the internet to connect to AWS, your data travels through many different networks, routers, and service providers. Each hop adds latency and introduces variability in performance. Some days your connection might be fast, other days it might be slow. With Direct Connect, you get a dedicated physical cable that connects your location directly to AWS infrastructure, bypassing the public internet entirely. The diagram on the slide shows the fundamental architecture. On the left side, we have your on-premises environment, which could be your corporate data center, a colocation facility, or even a large office building. This connects through a dedicated fiber optic connection to an AWS Direct Connect location. These locations are carrier-neutral colocation facilities where AWS has installed networking equipment. From there, the connection extends into the AWS cloud, giving you private access to your VPCs and AWS services. This architecture provides several key advantages that we will explore throughout this presentation, including consistent network performance, reduced bandwidth costs, and the ability to establish private connectivity that does not traverse the public internet. Understanding Direct Connect locations. AWS Direct Connect locations are the physical facilities where you establish your connection to AWS. Understanding how these locations work is essential for planning your Direct Connect implementation. Direct Connect locations are strategically placed carrier-neutral colocation facilities around the world. AWS partners with these facilities to install networking equipment called AWS Direct Connect endpoints. These endpoints are essentially the entry points into the AWS network. The locations are chosen based on geographic distribution to ensure customers worldwide can access Direct Connect services with minimal latency. When you want to establish a Direct Connect connection, you have two primary options. The first option is to physically rack your own equipment in the same Direct Connect location where AWS has its equipment. This is called a colocation arrangement. You would lease rack space from the facility, install your router, and then run a cross-connect cable from your equipment to the AWS endpoint. A cross-connect is simply a physical cable, usually fiber optic, that connects two pieces of equipment within the same facility. The second option, which is more common for smaller organizations, is to work with an AWS Direct Connect partner. These partners already have equipment and established connections in Direct Connect locations. They can provide you with a connection to AWS without requiring you to physically deploy your own hardware in the facility. This is much more cost-effective and faster to deploy if you need lower bandwidth connections, or want to avoid the complexity of managing colocation space. The diagram illustrates this architecture. Multiple customer networks can connect to AWS through a single Direct Connect location. Notice that the connections can come from different sources, such as colocation where customers have their own equipment, direct fiber connections from customer data centers if they are close enough, and through service provider networks that offer Direct Connect as a service. From the Direct Connect location, connections extend into AWS regions, providing access to VPCs and services within those regions. Virtual interfaces explained. Once you have established a physical Direct Connect connection, whether dedicated or hosted, you need to configure virtual interfaces, commonly abbreviated as VIFs, to actually use the connection. Understanding virtual interfaces is crucial because they determine what you can access over your Direct Connect connection. A virtual interface is a logical configuration that runs on top of your physical connection. Think of the physical connection as a pipe, and virtual interfaces as separate channels within that pipe. You can create multiple virtual interfaces on a single physical connection, and each virtual interface serves a different purpose. There are three types of virtual interfaces. Private virtual interfaces allow you to connect to resources within your VPCs using private IP addresses. When you create a private VIF, you attach it to a virtual private gateway or a direct connect gateway, which then connects to one or more VPCs. This gives you private access to EC2 instances, RDS databases, and other resources in your VPCs without traversing the public internet. The traffic uses private IP addresses from your VPC CIDR ranges. Public virtual interfaces allow you to connect to AWS public services using public IP addresses. This includes services like S3, DynamoDB, and other AWS services that normally have public endpoints. When you use a public VIF, your traffic still travels over the private Direct Connect connection rather than the internet, giving you better performance and security. However, you are accessing the public IP addresses of these services, not private endpoints. Transit virtual interfaces are used with AWS Transit Gateway to enable routing between multiple VPCs and your on-premises network. Transit Gateway acts as a central hub that can connect many VPCs together, and a Transit VIF allows your Direct Connect connection to interface with this hub. This is particularly useful in complex multi-VPC architectures where you need centralized routing and network management. The diagram illustrates how these virtual interfaces work together. Starting from your on-premises router, a single physical Direct Connect connection can carry multiple VIFs simultaneously. A private VIF connects to VPC resources through a virtual private gateway. A public VIF provides access to AWS public services. And a transit VIF connects through Transit Gateway to access multiple VPCs and potentially other Direct Connect connections. Configuring a private virtual interface. After your physical Direct Connect connection is established and showing as available, the next step is to create virtual interfaces to actually use the connection. Let me explain how to configure a private virtual interface, which is the most common type for accessing VPC resources. The Create Private Virtual Interface command requires several parameters. The connection ID parameter references the Direct Connect connection you created earlier. This tells AWS which physical connection this virtual interface should use. The virtual interface name is a descriptive name for this VIF to help you identify its purpose. The VLAN parameter is important. Direct Connect uses 802.1q VLAN tagging to multiplex multiple virtual interfaces over a single physical connection. Each VIF needs a unique VLAN ID between 1 and 4094. You can choose any VLAN ID that does not conflict with other VIFs on the same connection. Make sure your on-premises router is configured to tag traffic with the same VLAN ID. The ASN parameter stands for Autonomous System Number. This is required because Direct Connect uses BGP, the Border Gateway Protocol, to exchange routing information between your network and AWS. Your on-premises router needs to have a BGP ASN configured. If you do not have a public ASN assigned to your organization, you can use a private ASN in the range 64,512 to 65,534. AWS will use its own ASN on its side, and the two routers will establish a BGP peering session. The address family parameter specifies whether you are using IPv4 or IPv6. Most implementations use IPv4, but you can also configure IPv6 if your network supports it. The Amazon address and customer address parameters define the IP addresses for the point-to-point link between your router and the AWS router. These are typically configured as a /30 subnet in IPv4, giving you two usable IP addresses. For example, You might use 192.168.1.0/30, where 192.168.1.1 is the AWS side and 192.168.1.2 is your side. After creating the private VIF, you need to attach it to a virtual private gateway. The virtual private gateway is attached to your VPC and serves as the gateway for traffic coming from your Direct Connect connection. The command shown associates your newly created private VIF with the specified virtual private gateway ID. Once this association is complete and BGP routing is established, you will be able to route traffic between your on-premises network and your VPC over the Direct Connect connection. High availability architecture. High availability is critical for production environments, and AWS provides several options for building resilient Direct Connect architectures. Let me explain the best practices for achieving high availability with Direct Connect. A single Direct Connect connection creates a single point of failure. If that connection goes down due to a fiber cut, equipment failure, or facility issue, you lose connectivity to AWS for production workloads. AWS strongly recommends implementing redundancy. The most basic level of redundancy is to establish two separate Direct Connect connections to the same Direct Connect location. These should connect to different ports on the AWS equipment, and ideally to different routers in your on-premises infrastructure. If one connection fails, the other can continue to carry traffic. Both connections are active simultaneously, and BGP routing ensures traffic automatically fails over to the remaining connection if one goes down. For even higher availability, you should establish connections to two different Direct Connect locations. This protects against facility-level failures. If an entire Direct Connect location goes offline due to power outage or natural disaster, your connections in the second location remain operational. The diagram shows this architecture with connections from your on-premises network going to two separate Direct Connect locations, and from there into the AWS region. Each Direct Connect location should have at least one connection, and for maximum redundancy, you can have two connections per location for a total of 4 connections. This provides redundancy at both the connection level and the facility level. Naturally, this comes with increased cost, but for critical workloads, the investment is worthwhile. Another layer of availability is the hybrid approach, combining Direct Connect with vPages. You can establish an AWS site-to-site VPN connection over the Internet as a backup to your Direct Connect connection. The VPN provides an alternative path if all your Direct Connect connections fail. You configure BGP to prefer the Direct Connect path under normal conditions, but if Direct Connect becomes unavailable, traffic automatically fails over to the vPages. This gives you the performance and cost benefits of Direct Connect during normal operations, with the Internet-based VPN as a backup. Virtual private gateways support active-active or active-passive configurations. In an active-active setup, traffic is load balanced across multiple connections. In active-passive, one connection is preferred and the other is only used if the primary fails. You control this behavior using BGP attributes like AS path and local preference to influence which path traffic takes. Key benefits of AWS Direct Connect. Let me walk you through the primary benefits that make AWS Direct Connect such a compelling solution for enterprise customers. Understanding these benefits will help you determine whether Direct Connect is the right choice for your architecture. First and foremost is predictable network performance. When you connect to AWS over the Internet, you're sharing bandwidth with countless other users, and your traffic might take different paths each time. This leads to variable latency and throughput. With Direct Connect, you have a dedicated connection with guaranteed bandwidth. If you provision a 10 gigabit connection, you get 10 gigabits of dedicated bandwidth that is always available to you. This consistency is crucial for applications that require real-time data synchronization, video streaming, or large data transfers. The second major benefit is cost reduction for data transfer. AWS charges for data transfer out to the Internet, and these costs can add up significantly if you are moving large amounts of data. Direct Connect typically offers lower data transfer rates compared to internet-based transfers. For organizations moving terabytes of data monthly, the cost savings can be substantial and often justify the monthly port fee for the Direct Connect connection itself. Enhanced security is another critical advantage. Your data travels over a private connection that does not traverse the public internet. This means your traffic is not exposed to the same threats and vulnerabilities present on the public internet. While you should still encrypt sensitive data, the private nature of the connection adds an additional layer of security. Many compliance frameworks and regulatory requirements favor or even require private connectivity for certain types of data. Bandwidth scalability gives you the flexibility to start small and grow as your needs increase. You can begin with a 1 gigabit connection and later upgrade to 10 gigabits or even 100 gigabits. You can also establish multiple connections for even greater bandwidth or redundancy. This scalability ensures that your network infrastructure can grow alongside your business without requiring a complete redesign. Direct Connect connection types. AWS offers different types of Direct Connect connections to accommodate various bandwidth requirements and use cases. Choosing the right connection type is important for both cost optimization and meeting your performance needs. Dedicated connections are physical Ethernet ports that are dedicated exclusively to your AWS account. These connections come in 3 bandwidth options: 1 gigabit per second, 10 gigabits per second, and 100 gigabits per second. When you order a dedicated connection, AWS allocates a physical port on their equipment just for you. This port is not shared with any other customer, giving you the full bandwidth capacity at all times. The process of establishing a dedicated connection involves submitting a request through the AWS console, receiving a letter of authorization and connecting facility assignment, commonly called an LOACFA, and then working with the colocation facility to establish the cross-connect. The LOACFA is a document that authorizes the facility to connect your equipment to the AWS equipment. You present this document to the facility staff, and they will run the physical cable to complete the connection. Hosted connections, on the other hand, are provided by AWS Direct Connect partners. These partners maintain the physical connection to AWS and can provision portions of that bandwidth to multiple customers. Hosted connections are available in a wider range of bandwidth options, from as low as 50 megabits per second up to 10 gigabits per second. This flexibility makes hosted connections attractive for organizations that do not need a full dedicated connection or want to avoid the complexity of managing the physical infrastructure. With hosted connections, you work directly with the AWS partner, not with the colocation facility. The partner handles all the physical connectivity details. You simply accept the hosted connection in your AWS console, and the partner provisions your bandwidth. This makes deployment much faster and simpler. However, you will be working with the partner for billing and support, rather than directly with AWS for the connection itself. The table on the slide compares these two connection types across several important dimensions, including bandwidth options, whether the connection is dedicated to your account, deployment complexity, and typical use cases for each type. Creating a Direct Connect connection. Let me walk you through the process of creating a dedicated Direct Connect connection using the AWS CLI. Understanding this workflow will help you plan your implementation and know what to expect at each stage. The first command creates the Direct Connect connection itself. We use the AWS EC2 create Direct Connect connection command. But note that, despite the EC2 prefix, this command is actually part of the Direct Connect service. The location parameter specifies which Direct Connect facility you will be using. You need to choose a location that makes geographical sense for your on-premises infrastructure. The bandwidth parameter defines the port speed. In this example, we are requesting a 1 gigabit per second connection. The connection name is simply a friendly name to identify your connection in the AWS console. When this command executes successfully, AWS returns a connection ID, which is a unique identifier for your connection. At this point, AWS has reserved a port for you, but the connection is not yet active. The connection will be in a requested state. You will then receive the LOACFA document, which we discussed earlier. This document contains critical information including the port identifier on the AWS equipment and authorization for the colocation facility to complete the cross-connect. You take the LOACFA to your colocation provider or network team, and they will establish the physical fiber connection between your router and the AWS equipment. This process can take several days to a few weeks, depending on the facility and the complexity of the cabling required. Once the cross-connect is complete and both sides of the connection have their equipment properly configured, the connection status will change to available. You can verify this using the Describe Connections command shown in the code block. This command queries AWS for the current status of your Direct Connect connections and returns details including the connection state, bandwidth, location, and VLAN assignments. The highlight box emphasizes an important point. You must complete the physical cross-connect within 90 days of receiving the LOACFA, or AWS may automatically delete the connection reservation. This ensures that reserved ports are not left unused indefinitely. BGP routing and Direct Connect. Border Gateway Protocol, or BGP, is the routing protocol that makes Direct Connect work. Understanding BGP is essential for properly configuring and troubleshooting your Direct Connect connections. Let me explain how BGP operates in the Direct Connect context. BGP is a path vector protocol that routers use to exchange routing information and determine the best paths for traffic to reach different networks. In a Direct Connect setup, you have two BGP peers, your on-premises router and the AWS router at the Direct Connect location. These two routers establish a BGP session and advertise their routes to each other. The diagram shows the flow of BGP advertisements in a Direct Connect architecture. Starting from the on-premises side, your route advertises routes for your internal networks to AWS. For example, if your data center uses RFC 1918 network space, your route advertises this prefix to AWS via BGP. This tells AWS how to route traffic destined for your on-premises resources back through the Direct Connect connection. On the AWS side, the Virtual Private Gateway or Direct Connect Gateway advertises the VPC CIDR blocks to your router. If your VPC uses the RFC 1918 address space, AWS advertises this prefix to your router. Your router learns this route via BGP and installs it in its routing table, so it knows to send traffic for RFC 1918 through the Direct Connect connection. The BGP session establishment happens automatically once both sides are properly configured with the correct ASN, IP addresses, and authentication if MD5 authentication is enabled. The routers exchange OPEN messages to establish the session, then exchange UPDATE messages containing route advertisements. The session is maintained with periodic KEEPALIVE messages. One important aspect of BGP in Direct Connect is route filtering and summarization. You should carefully control which routes you advertise to AWS and which routes you accept from AWS. Advertising too many specific routes can cause issues, and accepting routes you do not need can fill up your routing table unnecessarily. Many organizations use route summarization to advertise aggregated prefixes rather than individual subnets, which keeps the routing table manageable and improves convergence time. BGP also supports path attributes that influence routing decisions. For example, you can use the BGP local preference attribute to prefer one Direct Connect connection over another if you have multiple connections. You can use AS path prepending to make certain routes less preferred. These advanced BGP features give you fine-grained control over traffic flow in complex network architectures. Direct Connect pricing components. Understanding Direct Connect pricing is important for budgeting and determining whether Direct Connect is cost-effective for your use case. The pricing model has several components that we need to examine. The first cost component is the port hour charge. This is a recurring monthly fee for the physical connection port. The cost depends on the port speed and the Direct Connect location. For example, a 1 gigabit port might cost around 30 cents per hour in a US location, which works out to approximately $216 per month. A 10 gigabit port might cost around $2.25 per hour, or approximately $1,620 per month. These prices vary by location, with some international locations charging more than US locations. The port hour charge applies whether you are actively using the connection or not, so it is a fixed recurring cost. The second cost component is data transfer out, commonly called DTO. This is the charge for data that you send from AWS to your on-premises network through the Direct Connect connection. The rates for Direct Connect DTO are typically lower than internet-based data transfer rates. For example, Direct Connect DTO might be 2 cents per gigabyte, while Internet DTO might be 9 cents per gigabyte. If you are transferring large amounts of data regularly, the savings on DTO can offset the port hour charges. An important pricing note is that data transfer into AWS is generally free, whether you use Direct Connect or the Internet. So you only pay for data leaving AWS also. Data transfer between AWS services within the same region over Direct Connect is free, similar to how it works for VPC traffic. For hosted connections, the pricing works differently. The AWS partner who provides the hosted connection sets their own pricing. Typically, this includes a monthly recurring charge for the provisioned bandwidth, plus data transfer charges. The partner essentially resells portions of their own dedicated connections to multiple customers. You should compare pricing from multiple partners to find the best value. There may be additional costs outside of AWS if you are placing your equipment in a colocation facility. You will pay the facility for rack space, power, and the cross-connect to the AWS equipment. Cross-connect fees can range from $50 to several $100s per month depending on the facility. If you are working with a network service provider to extend the connection from the Direct Connect location to your actual data center, you will pay the service provider for that circuit. The table on the slide breaks down the typical monthly costs for different configurations. For a 1 gigabit dedicated connection with moderate data transfer, you might expect monthly costs ranging from $300 to $500. This would include the port fee, data transfer, and colocation costs. For a 10 gigabit connection with high data transfer volumes, costs could range from $2,000 to $5,000 per month, or potentially more. Hosted connections for lower bandwidths might cost $100 to $300 per month, depending on the partner and the bandwidth tier. Direct Connect Gateway. Direct Connect Gateway is a powerful feature that solves a common challenge in multi-region AWS architectures. Let me explain the problem it solves and how it works. When you create a standard private virtual interface on a Direct Connect connection, you attach it to a virtual private gateway, and that virtual private gateway is associated with a single VPC in a single AWS region. This means if you want to access VPCs in multiple regions, you would traditionally need to establish separate Direct Connect connections to each region, which is expensive and complex to manage. Direct Connect Gateway changes this model. It acts as a global routing hub that sits between your Direct Connect connection and multiple virtual private gateways across different regions. You associate your private virtual interface with the Direct Connect gateway instead of directly with a virtual private gateway. Then you can attach multiple virtual private gateways from different regions to the same Direct Connect gateway. The diagram illustrates this architecture. Your on-premises network connects to a Direct Connect location through your physical connection. The private virtual interface on that connection associates with a Direct Connect gateway. This gateway is a global resource, not tied to any specific region. You then attach virtual private gateways from multiple AWS regions to this gateway. For example, you might attach a VGW from US East, another from US West, and another from Europe. Traffic from your on-premises network can now reach VPCs in all these regions through the single Direct Connect connection and the Direct Connect gateway. There are some important constraints to understand. First, the VPC CIDR blocks across all attached VPCs must not overlap. If you have a VPC in US East using 10.0.0.0/16, and a VPC in Europe also using 10.0.0.0/16, you cannot attach both to the same Direct Connect gateway, because the gateway would not know how to route traffic between these overlapping address spaces. Each VPC must have a unique CIDR block. Second, Direct Connect gateway does not perform routing between VPCs. It only routes traffic between your on-premises network and the VPCs. If you need VPC to VPC communication, you need to use VPC peering or transit gateway. The Direct Connect gateway is specifically for connecting your on-premises environment to multiple VPCs, not for inter-VPC connectivity. The benefit of the Direct Connect gateway is significant cost savings and simplified management. Instead of paying for multiple Direct Connect connections to different regions, you only pay for a single connection, and then use the Direct Connect gateway to reach all regions. AWS does not charge for the Direct Connect gateway itself. You only pay for the data transfer. Additionally, managing a single connection and a single BGP session is much simpler than managing multiple connections. MACsec encryption. MACsec, which stands for Media Access Control Security, is an IEEE standard for encrypting data at the Layer 2 level. AWS Direct Connect supports MACsec encryption for 10 gigabit and 100 gigabit dedicated connections, providing hardware-accelerated encryption for your Direct Connect traffic. Traditionally, if you wanted to encrypt data traveling over your Direct Connect connection, you would implement encryption at higher layers, such as IPsec VPN tunnels running over the Direct Connect connection, or TLS for application-level encryption. While these approaches work, they consume CPU resources on your routers and servers for encryption and decryption, which can limit throughput and add latency. MACsec operates differently. It encrypts traffic at the physical layer between your router and the AWS Direct Connect endpoint. The encryption and decryption happen in dedicated hardware on both ends, so there is minimal performance impact. MACsec provides line rate encryption, meaning you get the full bandwidth of your connection even with encryption enabled. The diagram shows the MACsec architecture. Your on-premises router must support MACsec, which requires specific hardware capabilities. When you enable MACsec on your Direct Connect connection, you generate a pre-shared key called the Connectivity Association Key, or CAK, and a CAK name, which is called the CKN. You configure these keys on your router and provide them to AWS. Both sides use these keys to establish the MACsec encryption session. Once the MACsec session is established, all traffic between your router and the AWS endpoint is encrypted at Layer 2. This includes not just your data traffic but also BGP routing protocol messages. The encryption is transparent to higher layer protocols. Your applications and operating systems are not aware that MACsec is running. They perceive the connection as a normal, unencrypted link, but the physical transmission is fully encrypted. MACsec provides several security benefits. It protects against eavesdropping on the physical cable between your router and AWS in a colocation environment. Multiple customers have equipment in the facility, and physical security cannot be guaranteed. MACsec ensures that even if someone gains physical access to your fiber connection, they cannot read the data. It also provides data integrity, ensuring that packets have not been tampered with in transit. To configure MACsec, Your router must support the MACsec standard and must be certified for use with AWS Direct Connect. AWS maintains a list of certified devices. You create or update your Direct Connect connection to request MACsec, generate the CAK and CKN, configure them on your router, and then associate the connection with a MACsec-capable port on the AWS side. The entire process can be done without downtime if you are updating an existing connection, as AWS supports MACsec key rotation. Troubleshooting common issues. Even with careful planning and configuration, you may encounter issues with Direct Connect. Let me walk through some common problems and how to diagnose and resolve them. The most common issue is BGP session failure. If your BGP session is not establishing, the first thing to check is IP connectivity between your router and the AWS router. You can ping the AWS router IP address from your router. If pings fail, the problem is at the physical or data link layer. Check that the cross-connect is properly installed, that the correct ports are connected, that both sides have the interface administratively up, and that VLAN tagging is correctly configured on both sides. If pings succeed, but BGP still does not establish, check the BGP configuration. Verify that both sides are using the correct ASN numbers. A mismatch in ASN will prevent BGP from establishing. Verify that the BGP neighbor IP addresses are correct. Your router should be configured to peer with the AWS router IP, and AWS is configured to peer with your router IP if you have configured MD5 authentication. Verify that both sides have the same MD5 key. Even a single character difference will prevent BGP from working. Another common issue is missing routes. Your BGP session is established, but traffic is not flowing. Use the show IPBGP command on your router to verify that you are receiving routes from AWS. You should see routes for your VPC CIDR blocks. If you are not receiving these routes, check that the virtual private gateway, or Direct Connect gateway, is properly attached to your VPCs, and that route propagation is enabled in your VPC route tables. In the VPC console, check the route table and verify that routes learned via BGP are appearing. Conversely, verify that you are advertising your on-premises routes to AWS. You can check the AWS Direct Connect console to see which routes AWS is receiving from you. If your routes are not appearing, check your router configuration. You may need to explicitly configure which networks to advertise, or use route redistribution to advertise routes from your IGP into BGP. Performance issues are another category of problems. If your connection is slower than expected, first verify that you are not hitting the bandwidth limit. Check CloudWatch metrics for bandwidth utilization. If you are consistently at 100% utilization, you need more bandwidth. If utilization is low but performance is poor, check for packet loss and errors. The show interface command on your router will display error counters. CRC errors suggest a physical layer problem, like a bad cable or transceiver. If you see drops or discards, the router may be oversubscribed or underpowered. Asymmetric routing can cause performance issues and connectivity problems. This happens when traffic in one direction takes a different path than traffic in the return direction. For example, traffic might flow from your office through Direct Connect to AWS, but return traffic might come back over a VPN connection. This can cause issues with stateful firewalls and can be confusing to troubleshoot. Use traceroute in both directions to verify the path, and adjust BGP metrics to ensure both directions use the same path. If you recently made configuration changes and issues started occurring, systematically revert changes one at a time to identify the culprit. It is helpful to maintain a change log documenting what was changed and when, so you can quickly identify recent modifications. Direct Connect Sitelink. AWS Direct Connect Sitelink is a feature that allows you to send data between your Direct Connect locations through the AWS Global Network, effectively using AWS as a private wide area network backbone for your on-premises locations. Traditionally, if you have multiple office locations or data centers, and each has a direct connect connection to AWS, traffic between those locations would have to route through your own WAN infrastructure or through AWS into a VPC and back out. SiteLink changes this by allowing traffic to flow directly between your direct connect connections using the AWS private backbone, without needing to route through a VPC. The diagram shows a SiteLink architecture. You have 3 locations: an office in New York, a data center in Dallas, and a branch office in London. Each location has its own Direct Connect connection to the nearest AWS Direct Connect location. Normally, if the New York office needs to communicate with the Dallas data center, that traffic would traverse your corporate WAN, or it would need to hairpin through an AWS VPC with SiteLink enabled. Traffic from New York can flow directly to Dallas through the AWS Global Network backbone, completely bypassing the public internet and your corporate WAN. To enable SiteLink, your Direct Connect connections must be associated with the same Direct Connect gateway. You enable the SiteLink feature on the Direct Connect gateway, and then traffic between your locations can traverse the AWS network. The routing is handled by BGP. Each location advertises its routes to the Direct Connect gateway, and the Direct Connect gateway advertises all routes to all locations. Your routers learn routes for the other locations via BGP and automatically route traffic through the Direct Connect connection to reach those remote networks. SiteLink is particularly useful for organizations that need to connect distributed locations without building their own expensive WAN infrastructure. Instead of buying MPLS circuits or point-to-point connections between every location, you only need a Direct Connect connection from each location to the nearest AWS facility. AWS provides the network between those facilities over its high-capacity, low-latency global network. The pricing for SiteLink is based on data transfer between locations. You pay a per gigabyte rate for data that flows between your Direct Connect connections. This rate is separate from the standard Direct Connect data transfer out pricing. You should compare the SiteLink data transfer costs against the cost of traditional WAN services to determine which is more economical for your usage patterns. One important point is that SiteLink traffic does not enter any VPC. It stays on the AWS backbone network and goes directly from one Direct Connect connection to another. This means you cannot use AWS services like firewalls or load balancers to inspect or modify the traffic. If you need centralized security inspection, you would need to route traffic through a VPC with security appliances, which is the traditional model rather than using SiteLink. SiteLink also provides excellent performance. The AWS Global Network is highly optimized with low latency and high bandwidth. In many cases, routing between locations through AWS SiteLink will provide better performance than routing through the public internet or even some private MPLS networks. Security best practices. While Direct Connect provides a private connection that does not traverse the public internet, you still need to implement security best practices to protect your infrastructure and data. Let me discuss the key security considerations for Direct Connect deployments. First, understand that Direct Connect itself does not encrypt traffic. The connection is private, meaning it does not go over the public internet, but it is not encrypted by default. Anyone with physical access to the fiber could theoretically intercept the data. For sensitive workloads, you should implement encryption. As we discussed earlier, MACsec provides Layer 2 encryption between your router and AWS, which is the most efficient option for 10 gigabits per second and 100 gigabits per second connections. Alternatively, you can run IPsec VPN tunnels over the Direct Connect connection, providing encrypted tunnels while still benefiting from the bandwidth and low latency of Direct Connect. Application-level encryption is also important. Even if you encrypt at the network level with MACsec or IPsec, you should still use TLS for web traffic, encrypt databases at rest and in transit, and follow your organization's data protection policies. Defense in depth means implementing security at multiple layers, not relying on a single control. Access control is critical. Restrict who can make changes to your Direct Connect configuration. In AWS, use IAM policies to control which users and roles can create or modify Direct Connect connections, virtual interfaces, and related resources. Follow the principle of least privilege, granting only the minimum permissions necessary. Enable CloudTrail logging to track all API calls related to Direct Connect, so you have an audit trail of configuration changes. On your on-premises side, implement physical security for your routers and network equipment. The Direct Connect connection terminates at your router, so if someone gains unauthorized access to that router, they could potentially intercept traffic or modify routing. Use secure access protocols, like SSH, with key-based authentication instead of passwords. Regularly update router firmware to patch security vulnerabilities. The diagram illustrates a defense in-depth security architecture for Direct Connect. Starting from the physical layer, you have MAC-SEC encrypting the Direct Connect link itself. Above that, you have network security groups and network ACLs in your VPCs controlling traffic at the network layer. Within your applications, you use TLS and application-level encryption. On the management plane, you have IAM policies controlling who can configure resources and CloudTrail logging all actions. Security groups act as virtual firewalls for your EC2 instances and other resources. Implement network segmentation. Do not give your entire on-premises network access to all your VPCs. Use careful route filtering in BGP to advertise only the necessary routes. On the AWS side, use route tables and security groups to control which on-premises subnets can reach which AWS resources. Consider using Transit Gateway with multiple route tables to implement network segmentation policies. Monitor for security anomalies. Enable VPC flow logs to capture information about IP traffic flowing through your VPCs. Analyze these logs for unusual patterns that might indicate a security issue. Use AWS GuardDuty for threat detection. Set up CloudWatch alarms for unexpected traffic volume or patterns. If you see traffic from unexpected source IPs or unusual amounts of data transfer, investigate immediately. Regularly review and audit your configuration. Direct Connect configurations can become complex over time as you add virtual interfaces, modify BGP policies, and make other changes. Periodically review your configuration to ensure it still aligns with your security policies and that no outdated or unnecessary rules remain. Document your security architecture and keep the documentation updated. Link Aggregation Groups. Link Aggregation Groups, or LAGs, allow you to combine multiple Direct Connect connections into a single logical connection for increased bandwidth and redundancy. This is particularly useful when you need more bandwidth than a single connection provides, or when you want active-active redundancy. A LAG groups multiple physical connections together and treats them as a single connection. For example, if you have 4 10 gigabit connections in a LAG, you effectively have 40 gigabits of aggregate bandwidth. Traffic is distributed across all the connections in the LAG using a load balancing algorithm, typically based on flow hashing. A flow is defined by source and destination IP addresses, ports, and protocol. All packets belonging to the same flow are sent over the same physical connection to maintain packet ordering, but different flows can be distributed across different connections. The diagram shows a LAG configuration with 4 physical connections between your on-premises router and the AWS Direct Connect location. These 4 connections are bundled into a single LAG from a configuration perspective. You create virtual interfaces on the LAG, not on individual connections. The VIF sees the LAG as a single interface with the combined bandwidth of all member connections. LAGs provide automatic failover. If one of the connections in the LAG fails, traffic automatically redistributes across the remaining connections. The LAG continues to function as long as at least one connection is active. When the failed connection is restored, it automatically rejoins the lag and starts carrying traffic again. This happens without any manual intervention or BGP reconvergence, making failover very fast, typically sub-second. There are specific requirements for creating a lag. All connections in the lag must have the same bandwidth. You cannot mix a 1 gigabit connection with a 10 gigabit connection in the same lag. All connections must terminate at the same direct connect location. You cannot create a lag with connections from different locations. All connections in the lag must use the same AWS device, though AWS handles this automatically when you create the lag. You can create a LAG with new connections or convert existing connections into a LAG when you create a new LAG. You specify how many connections you want, and AWS provisions them all together. If you already have standalone connections, you can migrate them into a LAG, though this requires some careful planning to avoid downtime. Typically, you would create a new LAG, establish new VIFs on it, migrate your traffic to the new VIFs, and then remove the old standalone connections. The maximum number of connections in an LAG depends on your configuration. By default, you can have up to 4 connections per LAG, but you can request a limit increase to support more connections if needed. AWS requires that at least half the connections in an LAG must be active for the LAG itself to be considered active. For example, in a 4-connection LAG, at least 2 connections must be up, otherwise the entire LAG is marked as down. Monitoring Direct Connect. Effective monitoring is essential for maintaining the health and performance of your Direct Connect connections. AWS provides several tools and metrics for monitoring Direct Connect. Understanding these tools will help you quickly identify and resolve issues. Amazon CloudWatch is the primary monitoring service for Direct Connect. AWS publishes several important metrics to CloudWatch for each Direct Connect connection and virtual interface. The connection state metric indicates whether the physical connection is up or down. This is the most basic health check. If this metric shows down, it means the physical layer is not working, possibly due to a fiber issue, equipment failure, or configuration problem. The connection BP's egress and connection BP's ingress metrics show the data transfer rate in bits per second for traffic leaving and entering AWS respectively. These metrics help you understand your bandwidth utilization. If you consistently see values approaching your connection bandwidth limit, you may need to upgrade to a higher bandwidth connection or add additional connections. These metrics are published at 1-minute intervals by default. The connection packets per second egress and connection packets per second ingress metrics show packets per second. This is useful for understanding the nature of your traffic. A high number of packets per second, especially with relatively low bits per second, suggests the presence of many small packets. These can be more challenging for routers to process. Such a scenario might indicate inefficient application behavior or potential security issues, such as a DDoS attack. For virtual interfaces, AWS provides the virtual interface bits per second egress and virtual interface bits per second ingress metrics, which show traffic per VIF if you have multiple VIFs on the same connection. These metrics help you understand which VIF is consuming bandwidth. Similarly, virtual interface packets per second egress and virtual interface packets per second ingress show packet rates per VIF. The connection light level TX and connection light level RX metrics are particularly important for detecting fiber issues. These metrics measure the optical signal strength of the transmitted and received light on the fiber connection. Light level that is too low might indicate a dirty fiber connector, excessive cable length, or a failing transceiver. Light level that is too high can also cause issues. AWS documentation provides acceptable ranges for these values, and you should set CloudWatch alarms to alert you if light levels fall outside the acceptable ranges. CloudWatch alarms allow you to receive notifications when metrics cross defined thresholds. For example, you might create an alarm that triggers if connection state shows down for more than 1 minute, or if bandwidth utilization exceeds 80% for a sustained period. Alarms can send notifications through Amazon SNS, which can deliver alerts via email, SMS, or integration with third-party incident management systems. AWS also provides Direct Connect specific monitoring in the AWS console. The Direct Connect console shows real-time connection status, recent BGP events, and virtual interface states. You can see when BGP sessions go up or down, which helps troubleshoot routing issues. The console also displays a graphical bandwidth utilization chart for quick visual assessment of traffic patterns. Direct Connect and Transit Gateway. AWS Transit Gateway integration with Direct Connect provides a highly scalable solution for connecting your on-premises network to many VPCs and across multiple AWS accounts. This combination is becoming the standard architecture for enterprise AWS deployments. Transit Gateway is a regional service that acts as a network hub, allowing you to connect multiple VPCs, VPN connections, and Direct Connect connections together. Instead of creating a mesh of VPC peering connections or using multiple virtual private gateways, you attach all your VPCs to a transit gateway, and the transit gateway handles routing between them. When you integrate Direct Connect with Transit Gateway, you create a transit virtual interface on your Direct Connect connection instead of a private virtual interface. The transit VIF attaches to a Direct Connect gateway, and the Direct Connect gateway associates with one or more transit gateways. This architecture allows a single Direct Connect connection to reach hundreds or even thousands of VPCs across multiple regions and accounts. The diagram illustrates this architecture. Your on-premises network connects via Direct Connect to a Direct Connect gateway. The Direct Connect gateway associates with transit gateways in multiple regions. Each transit gateway has multiple VPCs attached to it. Traffic from your on-premises network flows through the Direct Connect connection, through the Direct Connect gateway, to the appropriate transit gateway, and finally to the destination VPC. The routing is handled automatically based on BGP advertisements. Transit Gateway provides several advantages over the traditional virtual private gateway approach. First is scalability. A virtual private gateway can attach to only one VPC. Transit Gateway can attach to thousands of VPCs. Second is centralized routing policy. With Transit Gateway, you define routing policies centrally rather than configuring each VPC individually. Third is inter-VPC routing. Transit Gateway natively routes traffic between attached VPCs, eliminating the need for VPC peering meshes. Transit Gateway also supports segmentation through route tables. You can create multiple route tables within a transit gateway and attach different VPCs to different route tables. This allows you to control which VPCs can communicate with each other. For example, you might have a production route table and a development route table. VPCs in production cannot route to VPCs in development, providing network-level isolation even though they are attached to the same transit gateway. When you advertise routes from your on-premises network to AWS via Transit Gateway, you can control route propagation to individual VPCs. You might advertise your entire on-premises network range to some VPCs, but only specific subnets to other VPCs, implementing network segmentation and security policies. One important consideration is that Transit Gateway charges per attachment and per gigabyte of data processed. While the routing flexibility is valuable, you should factor these costs into your architecture decisions. For smaller deployments with only a few VPCs, the traditional virtual private gateway approach might be more cost-effective. For larger deployments with dozens or hundreds of VPCs, Transit Gateway becomes essential and cost-effective, despite the per gigabyte charges. Migration strategies. Migrating from internet-based connectivity to Direct Connect, or from an existing Direct Connect configuration to a new one, requires careful planning to minimize disruption. Let me share some strategies for successful migration. The first approach is a parallel migration. In this method, you establish the new Direct Connect connection alongside your existing connectivity method. For example, if you currently connect to AWS over the internet via VPN, you keep that VPN running while you set up Direct Connect. You create the Direct Connect connection, configure the virtual interfaces, establish BGP, and verify that routes are being exchanged. At this point, you have two paths to AWS: the existing VPN and the new Direct Connect connection. You then use BGP route manipulation to gradually shift traffic to the Direct Connect path. BGP allows you to prefer one path over another using attributes like local preference or AS path length. You can configure your routers to prefer the Direct Connect path, but keep the VPN path as a backup. Start by testing with non-critical traffic to verify everything works correctly. Monitor performance and stability. Once you are confident, you can shift production traffic by adjusting the BGP preferences. The VPN remains in place as a backup and can take over automatically if Direct Connect fails. The diagram shows this parallel migration strategy. Initially, all traffic flows over the existing VPN connection. You establish the Direct Connect connection in parallel. During the migration phase, you configure routing to prefer Direct Connect, but keep the VPN as backup. You can split traffic, sending some workloads over Direct Connect and others over VPN initially. Once fully migrated and stable, you can optionally decommission the VPN or keep it as a permanent backup for high availability. Another strategy is phased migration by workload. Instead of moving all traffic at once, you move one application or workload at a time. For example, you might first move your database replication traffic to Direct Connect because it is high volume and latency sensitive. You verify that the database replication works correctly over Direct Connect. Then you move your web application traffic. Then you move your file transfer workloads. This incremental approach reduces risk because if something goes wrong, only one workload is affected rather than your entire infrastructure. If you are migrating from one Direct Connect connection to another, perhaps to upgrade bandwidth or relocate, the process is similar. You establish the new connection, create new virtual interfaces, and set up BGP. You can keep both connections active temporarily. Use BGP local preference or other metrics to prefer the new connection. Once traffic has shifted and you have verified stability, you can decommission the old connection. If you are moving to ALAG, you might create the LAG and then migrate your virtual interfaces one at a time from standalone connections to the LAG. Testing is critical during migration. Before shifting production traffic, test thoroughly using non-production workloads or synthetic traffic. Verify that all routes are propagating correctly in both directions. Test failover scenarios by intentionally disabling BGP on the old path to ensure traffic shifts to the new path. Monitor latency, packet loss, and throughput. Have a rollback plan ready in case you encounter unexpected issues. Document the configuration steps and keep your network diagrams updated as you make changes. Real-world use cases. Let us walk through some real-world scenarios where Direct Connect provides significant value, helping you understand how organizations use this service in practice. The first common use case is hybrid cloud architecture for large enterprises. A financial services company might have extensive on-premises infrastructure including mainframes, databases, and applications that cannot easily move to the cloud due to regulatory requirements or technical constraints. However, they want to leverage AWS for new applications, big data analytics, and disaster recovery. Direct Connect provides the high bandwidth, low latency connection needed to integrate their on-premises systems with AWS. They can run web front ends in AWS that query databases on-premises with acceptable performance. They can replicate data from on-premises storage to S3 for backup. The consistent network performance ensures that latency-sensitive integrations work reliably. The second use case is big data and analytics workloads. A healthcare organization collects massive amounts of data from hospitals, clinics, and medical devices. This data resides in their data centers and needs to be transferred to AWS for processing with services such as Amazon EMR, Amazon Redshift, and machine learning services. Transferring terabytes or petabytes of data over the internet would be slow and expensive. Direct Connect provides the bandwidth needed for these large data transfers. With a 10 gigabits per second or 100 gigabits per second connection, they can transfer multiple terabytes per day. The lower data transfer costs compared to internet egress make this economically viable. Media and entertainment companies use Direct Connect for content distribution and rendering workflows. A video production company might render animations and special effects using AWS compute resources. The raw video files can be hundreds of gigabytes or even terabytes. Uploading these files over the internet would take days. With Direct Connect, they can transfer files quickly. They can also use AWS for transcoding, creating multiple versions of videos for different devices and bitrates, and then download the results back to their on-premises editing systems over the same Direct Connect connection. The diagram shows a multi-use case architecture. The on-premises environment connects via Direct Connect to AWS. Different workloads use different parts of the AWS infrastructure. Enterprise applications connect to RDS databases and EC2 compute instances for hybrid application architectures. Big data pipelines transfer data to S3 and process it with EMR and Redshift. Development teams use AWS for testing environments that need to access on-premises services. Backup and disaster recovery systems replicate data to AWS for off-site storage. All these workloads share the same Direct Connect connection but may use different virtual interfaces or routing policies. Another use case is disaster recovery. Organizations can use AWS as their DR site, replicating data continuously over Direct Connect. If their primary data center fails, they can fail over to AWS. Direct Connect ensures that the replication has minimal latency and can keep up with changes in the production systems. Some organizations implement active-active architectures where workloads run simultaneously on premises and in AWS, with Direct Connect providing the low-latency connectivity required for data synchronization. Finally, Direct Connect is valuable for multi-cloud architectures. Some organizations use multiple cloud providers for different workloads or to avoid vendor lock-in. They might have their core infrastructure in their own data center, some workloads in AWS, others in Azure or Google Cloud. Direct Connect to AWS, combined with similar services from other providers, creates a private, interconnected network spanning multiple clouds and on-premises sites. This architecture requires careful routing and network design but provides the flexibility to choose the best platform for each workload. Cost optimization strategies. Managing costs effectively is crucial when deploying Direct Connect, as the service involves recurring charges and potentially significant data transfer volumes. Let me walk through strategies to optimize your Direct Connect costs without sacrificing performance or reliability. The first strategy is right-sizing your connection bandwidth. Many organizations overestimate their bandwidth requirements and pay for capacity they do not use. Before ordering a Direct Connect connection, analyze your actual data transfer patterns. Monitor your current internet-based AWS traffic to understand peak usage times and average throughput. If your analysis shows you need 3 gigabits per second of bandwidth, a single 10 gigabit connection might be overkill. Instead, you could start with a 1 gigabit hosted connection and upgrade if needed, or use multiple lower bandwidth connections that provide both right-sized capacity and redundancy. Data transfer costs are where you can achieve significant savings. Direct Connect data transfer out rates are typically much lower than internet-based egress charges. For example, internet egress might cost 9 cents per gigabyte while Direct Connect egress might cost 2 cents per gigabyte. If you transfer 50 terabytes per month from AWS to on-premises, That is a difference of $3,500 versus $1,000, saving $2,500 per month. At this volume, the savings easily cover the port hour charges and make Direct Connect economically attractive. However, not all traffic should necessarily route through Direct Connect. Traffic to AWS public services like S3 can go over either a public virtual interface on Direct Connect or over the Internet. If you have an existing Internet connection with available capacity, routing some traffic types over the Internet while keeping latency-sensitive traffic on Direct Connect can save data transfer costs. This requires careful routing configuration but can be worthwhile for cost optimization. The diagram shows a cost analysis decision tree. You start by evaluating your monthly data transfer volume. If you transfer less than 5 terabytes per month, the Direct Connect port charges may exceed your savings on data transfer, making internet connectivity more economical. Between 5 and 20 terabytes, a hosted connection with lower port charges makes sense. Above 20 terabytes, dedicated connections become cost-effective. The exact breakpoint depends on your specific pricing from AWS and your service provider, but this provides a general framework. Consider using AWS Cost Explorer and AWS budgets to track your Direct Connect spending. Tag your Direct Connect resources appropriately so you can allocate costs to specific projects or departments. Set up budget alerts to notify you if costs exceed expected thresholds. Review your CloudWatch metrics monthly to ensure you are not paying for unused capacity. For multi-region architectures, leverage Direct Connect Gateway to avoid paying for multiple Direct Connect connections to each region. A single connection with Direct Connect Gateway can reach multiple regions, with data transfer charged only once. Compare this to establishing separate connections to each region, which would multiply your port hour charges. If you have consistent high-volume data transfers, negotiate with AWS or your Direct Connect partner for volume discounts or reserved capacity pricing. Some partners offer discounted rates for long-term commitments. This is similar to using reserved instances for EC2, where committing to a term provides cost savings. Infrastructure as code for Direct Connect. Managing Direct Connect infrastructure as code provides consistency, repeatability, and version control for your network configurations. Let me show you how to use AWS CloudFormation and Terraform to automate Direct Connect deployments. Infrastructure as code, commonly called IAC, treats your infrastructure configuration as software code that can be versioned, reviewed, and deployed automatically. Instead of manually clicking through the AWS console to create Direct Connect resources, you define the desired configuration in a template file, and automation tools create the resources for you. This approach reduces human error, ensures consistency across environments, and provides a documented history of all changes. The code block shows a CloudFormation template for creating a Direct Connect virtual interface. The template is written in YAML format. At the top, we define the resource type as AWS Direct Connect virtual interface. The Properties section specifies all the configuration parameters. The connection ID references the existing physical Direct Connect connection. The virtual interface name provides a descriptive name. The VLAN specifies the VLAN ID for 802.1q tagging. The ASN is your BGP autonomous system number. The address family specifies IPv4 or IPv6. The Amazon address and customer address define the point-to-point IP addresses for the BGP session. Once you have defined this template, you use the AWS CloudFormation CLI or console to create a stack from the template. CloudFormation reads the template and makes the necessary API calls to create the virtual interface with the specified configuration. If you need to update the configuration later, you modify the template and update the stack. CloudFormation automatically determines what changes are needed and applies them. Terraform is an alternative to CloudFormation that works across multiple cloud providers. The Terraform configuration uses HCL syntax, which is slightly different from YAML but follows similar concepts. You define resources in Terraform configuration files, run Terraform plan to preview what changes will be made, and then run Terraform apply to create or update the infrastructure. Terraform maintains state information about your infrastructure, allowing it to determine what needs to be created, modified, or destroyed when you make changes. The advantage of infrastructure as code extends beyond initial deployment. When you need to create similar resources in different environments or different AWS accounts, you can reuse the same templates with different parameter values. You can store your infrastructure code in version control systems like Git, providing a complete audit trail of who made what changes and when. You can implement code review processes where team members review proposed infrastructure changes before they are applied, just like you would review application code changes. For complex Direct Connect architectures with multiple virtual interfaces, Direct Connect gateways, and associations with transit gateways or virtual private gateways, infrastructure as code becomes essential. Manually creating and managing dozens of interconnected resources is error-prone and difficult to document. With IAC, your templates serve as both the deployment mechanism and the documentation of your architecture. You can also integrate infrastructure as code with CI/CD pipelines to automate testing and deployment. For example, you might have a pipeline that automatically validates your templates for syntax errors, checks them against security policies, deploys them to a test environment, runs automated tests, and then deploys to production only if all tests pass. This level of automation is difficult to achieve with manual, console-based management. Direct Connect versus alternatives. Direct Connect is a powerful solution, but it is not always the right choice for every scenario. Understanding how Direct Connect compares to alternative connectivity options will help you make informed architecture decisions. The most common alternative is AWS Site-to-Site VPN, which establishes encrypted tunnels over the Internet to connect your on-premises network to AWS versus PN is much simpler and faster to deploy than Direct Connect. You can have a VPN connection operational in minutes, whereas Direct Connect typically takes weeks to provision due to the physical cross-connect process. VPN requires no special hardware beyond your existing internet connection and a VPN-capable router or firewall. However, VPN has significant limitations compared to Direct Connect. Performance is unpredictable because you are traversing the public internet, which is subject to congestion, packet loss, and variable latency. VPN throughput is limited by your internet connection bandwidth and by the cryptographic processing capabilities of your VPN endpoint. Most VPN implementations top out at a few hundred megabits per second, whereas Direct Connect can provide up to 100 gigabits per second. The table on the slide compares Direct Connect with Site-to-Site VPN and AWS VPN over Direct Connect across multiple dimensions. Direct Connect provides consistent performance, scales to very high bandwidth, and costs more due to port fees, but offers lower data transfer rates. VPN over the Internet provides variable performance, limited bandwidth, a low initial cost, but higher data transfer rates, and is quick to deploy. VPN over Direct Connect combines the best of both worlds. It provides the consistent performance of Direct Connect with the encryption of vPages N. However, it requires the Direct Connect setup time and combines costs from both services. Another option is SD-WAN solutions integrated with AWS. Many SD-WAN vendors offer AWS integration where their appliances can establish connections to AWS and optimize traffic routing. SD-WAN can aggregate multiple connections, including broadband internet, MPLS, and Direct Connect, providing intelligent path selection based on application requirements. For organizations already using SD-WAN, this can provide a unified management approach for all WAN connectivity, including AWS. AWS Private Link is an alternative for specific use cases where you need to access AWS services or services hosted by third parties without traversing the public internet. Private link creates a private endpoint in your VPC that represents a service. Traffic to that endpoint stays within the AWS network. Private link is useful for accessing specific services but does not provide general connectivity like Direct Connect does. For very low bandwidth requirements, say less than 100 megabits per second, and for non-latency sensitive workloads, internet-based connectivity without VPN might be sufficient. Many AWS services like S3 and DynamoDB work perfectly well over internet connections. If your use case is simply uploading files to S3 or making API calls to AWS services, the complexity and cost of Direct Connect might not be justified. The decision criteria shown in the diagram help guide your choice. Start by evaluating bandwidth requirements. If you need more than 1 gigabit consistently, Direct Connect is likely necessary. Next, consider latency sensitivity. Real-time applications benefit greatly from Direct Connect's consistent low latency. Evaluate data transfer volume because Direct Connect's cost-saving scale with volume. Consider compliance requirements, as some regulations may require private connectivity. Finally, factor in deployment timeline. If you need connectivity operational quickly, start with VPN and migrate to Direct Connect later. Performance optimization. Even with Direct Connect providing consistent network performance, there are configuration and architecture choices that can further optimize performance for your specific workloads. Let me explain key optimization techniques. MTU size, which stands for Maximum Transmission Unit, is the size of the largest packet that can be transmitted over a network link. Direct Connect supports jumbo frames with MTU sizes up to 9001 bytes, compared to the standard Internet MTU of 1500 bytes. Using jumbo frames reduces the number of packets needed to transmit the same amount of data, which reduces overhead and can significantly improve throughput for large data transfers. To use jumbo frames, you must configure the MTU on both your on-premises router and in your VPC. All devices in the path must support the larger MTU, or packets will be fragmented, which actually hurts performance. TCP window scaling is important for high bandwidth, high latency connections. The TCP window size determines how much data can be in flight before receiving an acknowledgement. For high bandwidth connections, you need large TCP windows to fully utilize the available bandwidth. Modern operating systems support TCP window scaling by default, but you should verify it is enabled on your servers and applications. Application-level tuning may also be necessary. Some applications have their own buffer sizes and timeout settings that need adjustment for optimal performance over Direct Connect. The diagram illustrates performance optimization layers. At the physical layer, you have the Direct Connect bandwidth itself, and you should ensure you are not consistently saturating the connection. If you regularly hit 100% utilization, you need more bandwidth. At the network layer, configure jumbo frames, optimize BGP routing to minimize unnecessary hops, and use LAG for connection-level load balancing. At the transport layer, tune TCP parameters including window size, congestion control algorithms, and keep alive settings. At the application layer, optimize how applications use the network, such as implementing connection pooling, caching, and data compression. Network latency is determined by physical distance and the number of hops. Choose Direct Connect locations that are geographically close to both your on-premises location and the AWS region you need to access. For example, if your data center is in Chicago and you primarily use AWS resources in the US East region, choose a Direct Connect location in Chicago that has low latency connectivity to US East. Avoid routing traffic through unnecessary intermediate locations. For multi-region architectures, consider using AWS Global Accelerator in combination with Direct Connect. Global Accelerator provides static IP addresses that route traffic to the optimal AWS region based on latency and health. Traffic enters the AWS network at the closest point and then traverses the AWS Global Network backbone, which is highly optimized. This can provide better performance than routing between regions over your own network or the public internet. Application-level optimization is equally important. If you are transferring large files, use tools that support parallel transfers, like the AWS CLIS3 sync with multiple threads, or tools specifically designed for large data transfers, like AWS Data Sync. These tools can saturate high-bandwidth connections more effectively than single-threaded transfers. Implement compression for data that compresses well, which reduces the amount of data transmitted and can effectively multiply your available bandwidth. Monitor performance continuously using CloudWatch metrics and your own application performance monitoring tools. Establish baselines for normal performance so you can quickly identify when performance degrades. Set up alarms for latency spikes, throughput drops, or packet loss. When performance issues occur, use tools like traceroute, MTR, and iPerf to diagnose where bottlenecks exist. The issue might be in your on-premises network, the Direct Connect connection itself, within AWS networking, or at the application level. Systematic monitoring and testing help isolate the root cause. Future-proofing your network. Network architecture decisions have long-lasting implications. A well-designed Direct Connect architecture should accommodate future growth and changing requirements without requiring complete redesigns. Let me share strategies for building networks that remain effective as your needs evolve. Start by planning for bandwidth growth. Historical data shows that network bandwidth requirements typically double every 18 to 24 months for organizations undergoing cloud migration or expanding their cloud usage. When designing your Direct Connect architecture, provision capacity not just for current needs but for anticipated growth over the next 2 to 3 years. If you currently need 2 gigabits per second, plan for 8 to 10 gigabits within 3 years. Using LAG from the start provides an easy upgrade path by adding more connections to the group. IP addressing is a common area where poor initial planning causes problems later. Choose VPC CIDR blocks carefully, ensuring they do not overlap with your on-premises networks or with each other if you plan to use Direct Connect Gateway or Transit Gateway. Leave room for growth in your addressing scheme. If you use 10.0.0.0/16 for your first VPC, do not use 10.1.0.0/16 for your second. Instead, use non-contiguous address blocks or leave gaps that allow you to create summarized routes later. A poorly planned IP scheme can force you into complex routing workarounds or even require renumbering VPCs, which is extremely disruptive. The diagram shows a mind map of future-proofing considerations. At the center is your network architecture strategy. Branching from this is capacity planning, including bandwidth growth projections and connection scalability. Another branch focuses on IP address design, incorporating non-overlapping CIDRs and route summarization capability. A third branch covers architectural flexibility, including Transit Gateway for multi-VPC scaling and Direct Connect Gateway for multi-region expansion. A fourth branch addresses technology evolution, with support for new AWS services and emerging protocols. The final branch is operational readiness, including automation with infrastructure as code and documentation maintenance. Choose architectural patterns that scale. Transit Gateway is more scalable than Virtual Private Gateway for multi-VPC scenarios. Direct Connect Gateway is essential for multi-region deployments. Even if you start with a single VPC in one region, designing your architecture with Transit Gateway and Direct Connect Gateway from the beginning makes future expansion much easier. The incremental cost of these services is minimal compared to the cost of architectural redesigns later. Embrace automation and infrastructure as code from day one. As discussed earlier, managing Direct Connect infrastructure as code provides consistency and repeatability. When you need to expand your architecture, you modify templates rather than manually clicking through consoles. This becomes increasingly important as your environment grows. An architecture that works well for 5 VPCs might become unmanageable at 50 VPCs without automation. Stay informed about AWS service evolution. AWS regularly announces new networking features and services. Recent years have brought SiteLink, MAC-Sec support, 100 gigabit connections, and various transit gateway enhancements. Subscribe to AWS networking blogs and attend AWS events to learn about new capabilities. Periodically review your architecture against new features to identify opportunities for improvement or simplification. Document your architecture thoroughly and keep documentation updated. When you make changes, update diagrams and documentation immediately. Include not just what the architecture is, but why design decisions were made. Future team members, or your future self, will need to understand the reasoning behind choices to make informed decisions about changes. Use tools like Lucidchart, Draw.io, or AWS architecture icons to create clear, professional diagrams. Build operational excellence through monitoring, alerting, and runbooks. As your Direct Connect environment grows, you need robust operational practices. Automated monitoring catches issues before they impact users. Clear runbooks enable quick response to problems. Regular testing validates that failover mechanisms work. These practices scale better than relying on individual expertise and tribal knowledge. Compliance and regulatory considerations. Many organizations adopt Direct Connect specifically to meet compliance and regulatory requirements. Understanding how Direct Connect fits into various compliance frameworks will help you design architectures that satisfy auditors and regulators. A key compliance driver is data residency and sovereignty requirements. Some regulations mandate that certain types of data must not traverse the public internet or must remain within specific geographic boundaries. Direct Connect provides a private connection that does not use the public internet, which satisfies many of these requirements. When combined with AWS regions located in the appropriate geography, you can ensure data stays within required jurisdictions. For example, healthcare organizations subject to HIPAA regulations must ensure protected health information is adequately secured in transit. While HIPAA does not explicitly require private connections, the private nature of Direct Connect combined with encryption provides strong assurance that PHI is protected. Financial services companies subject to PCI DSS must ensure cardholder data is encrypted during transmission. Using Direct Connect with MAC-Sec or IPsec VPN tunnels provides multiple layers of encryption that satisfy PCI requirements. Government and defense organizations often require connections that meet specific security standards, such as FIPS 142, for cryptographic modules. AWS Direct Connect locations can support these requirements when properly configured. The routers and encryption mechanisms used must be FIPS validated. AWS provides documentation on which Direct Connect configurations meet FIPS compliance. The diagram illustrates a compliance architecture stack. At the foundation is the physical layer with Direct Connect providing private connectivity. Above that, encryption layers using MAC-Sec or IPsec provide data protection. Network segmentation using security groups, NACLS, and separate VPCs provides isolation between different data classification levels. Access controls using IAM policies and multi-factor authentication protect the management plane. At the top, logging and monitoring with CloudTrail, VPC flow logs, and CloudWatch provide the audit trails required by most compliance frameworks. Many compliance frameworks require logging and audit trails. Enable CloudTrail logging for all Direct Connect API calls to track who creates or modifies connections and virtual interfaces. Enable VPC flow logs to capture information about IP traffic flowing through your network. Retain these logs for the period required by your compliance framework, typically at least 1 year and often longer. Use S3 bucket policies and object locks to ensure logs cannot be tampered with or deleted prematurely. Regular compliance assessments and penetration testing are required by many frameworks. When planning penetration tests that involve Direct Connect, ensure you follow AWS policies for penetration testing. Some types of testing require advance notification to AWS. Document your Direct Connect architecture thoroughly, including network diagrams, data flow diagrams, and security controls documentation. Auditors will want to review these materials as part of compliance assessments. For international data transfers, understand how Direct Connect interacts with regulations like GDPR in Europe. The private nature of Direct Connect can be part of your data protection impact assessment, demonstrating appropriate technical and organizational measures to protect personal data during transfer. If you are using AWS services in Europe and transferring data back to on-premises locations outside Europe, ensure you have proper legal mechanisms in place such as standard contractual clauses. Advanced BGP configurations. Border Gateway Protocol provides powerful capabilities for controlling traffic flow in Direct Connect architectures. Understanding advanced BGP features allows you to implement sophisticated routing policies that optimize performance and costs. BGP communities are one of the most useful advanced features. Communities are tags that you can attach to BGP route advertisements to signal routing policies. AWS supports specific BGP communities that influence how AWS routes traffic. For example, you can use BGP communities to advertise routes only to specific regions, or to set local preference values that control how traffic returns from AWS to your network. The diagram shows how BGP attributes influence route selection. When your on-premises router receives route advertisements from AWS via multiple Direct Connect connections, BGP uses a decision process to choose the best path. This process evaluates attributes in a specific order. The first attribute considered is local preference, which is locally significant to your router. Higher local preference values are preferred. You can set different local preferences on routes learned from different connections to prefer one path over another. If the local preference is equal, BGP looks at AS path length. Routes with shorter AS paths are preferred. You can artificially make one path less preferred by prepending your ASN multiple times in the AS path. For example, if you advertise routes through one Direct Connect connection with a normal AS path, and through another connection with your ASN prepended 3 times, AWS will prefer the shorter path. This technique is useful for implementing active-passive failover scenarios where you want traffic to use one connection unless that connection fails. The multi-exit_disk attribute, commonly called MED, is used to influence inbound traffic from AWS when you advertise the same prefix to AWS through multiple locations. You can set different MED values. AWS will prefer the path with the lower MED value. This allows you to signal to AWS which entry point into your network is preferred for specific routes. For example, if you have Direct Connect connections in both New York and California, you might set lower MED values on the New York connection for your East Coast networks and lower MED values on the California connection for your West Coast networks, ensuring traffic enters your network at the geographically closest point. Route filtering is essential in production Direct Connect environments. You should not advertise your entire routing table to AWS. Instead, use prefix lists or access lists on your router to filter which routes are advertised. Typically, you want to advertise only your summarized internal networks, not individual host routes or routes learned from external sources. On the inbound side, you should filter routes received from AWS to accept only the VPC CIDR blocks and AWS service IP ranges you actually need. BGP route dampening helps protect against route flapping, where routes repeatedly appear and disappear, causing routing instability. When a route flaps, BGP increments a penalty counter. If the penalty exceeds a threshold, the route is suppressed for a period. This prevents unstable routes from disrupting your network. However, be cautious with dampening in Direct Connect environments because overly aggressive dampening can cause legitimate failover events to take longer than necessary. Bidirectional forwarding detection, or BFD, is a protocol that provides fast failure detection for BGP sessions. Normally, BGP keep alive timers are typically 60 seconds with a hold time of 180 seconds, meaning it can take up to 3 minutes to detect a failed BGP session. BFD can detect failures in sub-second timeframes. When you enable BFD on your BGP sessions with AWS, failure detection and convergence are much faster, reducing downtime during failure scenarios. BFD is supported on Direct Connect and should be enabled for production deployments where fast failover is important. Resiliency testing. Having redundant Direct Connect connections is only valuable if they actually fail over correctly when needed. Regular resiliency testing ensures your failover mechanisms work as expected before you experience a real failure. Resiliency testing involves intentionally causing failures in a controlled manner and verifying that your systems handle the failures gracefully. For Direct Connect, this means testing scenarios like individual connection failures, entire facility failures, BGP session failures, and routing failures. Each scenario tests different aspects of your architecture. The simplest test is to intentionally disable one Direct Connect connection when you have redundant connections. You can do this by administratively shutting down the interface on your router or by disabling the BGP session. Monitor your traffic to verify that it seamlessly shifts to the backup connection. Measure how long the failover takes. With properly configured BGP and BFD, failover should occur in seconds. Check that all applications continue to function and that users do not experience significant disruption. A more comprehensive test involves simulating a complete Direct Connect location failure. If you have connections to 2 different Direct Connect locations for redundancy, disable all connections to one location. This tests whether your routing can handle losing an entire facility. Verify that traffic routes through the remaining location and that performance remains acceptable with the reduced available bandwidth. The diagram shows a testing workflow. You begin by documenting the expected behavior during the failure scenario. What should happen when connection fails? Which path should traffic take? How long should failover take? Then you schedule the test during a maintenance window or low traffic period to minimize impact. Execute the failure by disabling the connection or BGP session. Monitor the environment using CloudWatch metrics, your on-premises monitoring tools, and application-level checks. Document the actual behavior. Did traffic fail over as expected? Were there any application errors? How long did the failover take? After testing, restore the failed component and verify that everything returns to normal. Finally, analyze the results and make improvements to your configuration if needed. Test not just the failure scenario, but also the restoration scenario. When the failed connection comes back online, does traffic rebalance correctly? Some BGP configurations can cause all traffic to suddenly shift when a previously failed path is restored, which can cause its own disruption. You want traffic to rebalance smoothly. Consider testing degraded scenarios, not just complete failures. What happens if one connection becomes congested but does not completely fail? Does BGP reroute traffic appropriately, or does traffic continue to use the degraded path? You might need to configure advanced BGP features or use application-aware routing to handle these scenarios. Document your test procedures and results. Create a runbook that describes exactly how to perform each test, what to monitor, and what the expected results are. After each test, document what happened and any configuration changes made. Over time, this documentation becomes a valuable resource for troubleshooting real failures because you will have a known baseline of how your system behaves during failures. Automate testing where possible. Some organizations use chaos engineering principles to automatically and randomly inject failures into their infrastructure to ensure systems remain resilient. While this level of automation might not be appropriate for Direct Connect connections, you can at least automate the monitoring and validation parts of your testing. Scripts can check BGP routing tables, query CloudWatch metrics, and run application-level health checks, providing objective pass/fail results for your tests. Multi-account architecture. Large organizations typically use multiple AWS accounts to isolate workloads, separate environments, or organize by business unit. Direct Connect can span multiple accounts through several different architectural patterns. Understanding these patterns is crucial for enterprise-scale deployments. The simplest multi-account pattern uses a centralized networking account that owns the Direct Connect connections and shares them with other accounts. In this model, you create the Direct Connect connection, Direct Connect gateway, and Transit gateway in a dedicated networking account. Other accounts attach their VPCs to the Transit gateway using AWS Resource Access Manager, or RAM, which allows sharing of certain AWS resources across accounts. The diagram illustrates this architecture. The networking account at the center owns the Direct Connect infrastructure, including the physical connection, virtual interfaces, and Direct Connect gateway. This gateway connects to a Transit gateway, also owned by the networking account. 3 separate AWS accounts, representing development, production, and shared services, each have their own VPCs. These VPCs are attached to the Transit gateway via shared attachments. Traffic from on-premises flows through the Direct Connect connection in the networking account, through the Transit gateway, and then to VPCs in the individual accounts. This centralized model provides several benefits. First is simplified management. The network team manages all Direct Connect resources in one place. They control route policies, monitor performance, and handle troubleshooting without needing access to application accounts. Second is cost allocation. You can use AWS cost allocation tags and cost categories to track Direct Connect costs centrally but allocate them to individual accounts based on usage. Third is security and governance. The networking account can enforce consistent security policies, route filtering, and access controls across all accounts. Resource Access Manager is key to implementing this architecture. RAM allows you to share Transit gateway attachments with other accounts. From the networking account, you create a resource share that includes your Transit gateway and specify which AWS accounts can use it. Those accounts can then create VPC attachments to the shared Transit gateway. The networking account retains control over the Transit gateway routing tables and policies, while application accounts can connect their VPCs without needing permission to modify the core networking infrastructure. An alternative pattern is to use VPC peering to connect VPCs across accounts to a central networking VPC that has the Direct Connect attachment. In this model, the networking account has a VPC with a virtual private gateway connected to Direct Connect. Other accounts peer their VPCs to this central networking VPC. However, this pattern has limitations. VPC peering is not transitive, meaning traffic from one application VPC cannot route through the networking VPC to reach another application VPC. Each VPC needs a separate peering connection to communicate. For large numbers of VPCs, the Transit gateway approach is much more scalable. Some organizations implement a hybrid model where each business unit or geographic region has its own Direct Connect connection in a regional networking account, and then those regional accounts connect to individual application accounts. This provides distributed management while still maintaining centralized control at the regional level. The architecture pattern you choose depends on your organization structure, management preferences, and the scale of your AWS deployment. For billing and chargeback, use tagging extensively. Tag all Direct Connect resources, Transit gateways, and VPC attachments with cost center, business unit, and project identifiers. Enable cost allocation tags in the AWS Billing Console. Use AWS Cost Explorer to analyze costs by tag, allowing you to generate reports showing how much each business unit or project is consuming. Some organizations implement automated chargeback systems that read AWS cost and usage reports and allocate networking costs to internal departments based on their actual usage. Summary and next steps. We have covered a comprehensive overview of AWS Direct Connect, from fundamental concepts to advanced architectural patterns. Let me summarize the key points and suggest next steps for implementing Direct Connect in your environment. Direct Connect provides dedicated private connectivity between your on-premises infrastructure and AWS, offering consistent performance, lower data transfer costs, and enhanced security compared to internet-based connectivity. It works by establishing physical connections through AWS Direct Connect locations worldwide, using BGP to exchange routing information, and supporting virtual interfaces to access VPCs and AWS services. For production deployments, implement redundancy by establishing multiple Direct Connect connections, preferably to different Direct Connect locations. Combine Direct Connect with VPN for a hybrid approach that provides backup connectivity. Monitor your connections using CloudWatch metrics and set up alarms for critical thresholds. Implement proper security with encryption through MAC-sec or IPsec, network segmentation, and access controls. Use Direct Connect Gateway to access multiple AWS regions through a single connection, which reduces costs and complexity. For large multi-VPC environments, leverage Transit Gateway to provide centralized routing and scalable connectivity. In multi-account organizations, use a centralized networking account with shared Transit Gateway attachments to simplify management while maintaining security boundaries. The diagram shows a recommended implementation roadmap. Phase 1 is planning and assessment, where you analyze bandwidth requirements, evaluate costs, design IP addressing, and obtain stakeholder approval. Phase 2 is initial deployment, where you order Direct Connect connections, establish cross-connects, configure basic virtual interfaces, and implement monitoring. Phase 3 is optimization, where you tune performance parameters, implement redundancy and high availability, and establish operational procedures. Phase 4 is expansion, where you add connections for additional bandwidth, integrate with Transit Gateway for multi-VPC support, extend to multiple regions via Direct Connect Gateway, and implement advanced BGP policies. For organizations just starting with Direct Connect, begin with a pilot deployment for non-critical workloads. This allows you to gain experience with the technology and validate performance benefits before migrating production traffic. Start with a hosted connection if you need lower bandwidth, as it is faster and simpler to provision than dedicated connections. As your comfort level and requirements grow, upgrade to dedicated connections and implement full redundancy. Continue learning through AWS documentation, whitepapers, and training. The AWS Direct Connect User Guide provides detailed technical information. AWS well-architected framework includes best practices for networking. AWS offers training courses specifically focused on advanced networking topics. Engage with the AWS community through forums and user groups to learn from others who have implemented Direct Connect. Consider working with AWS partners who specialize in networking if you need assistance with design or implementation. AWS Partner Network includes numerous consulting partners and technology partners who provide Direct Connect services, managed services, and integration expertise. For complex deployments, professional services can accelerate implementation and help avoid common pitfalls. Thank you for your attendance. Please consider subscribing to the channel and liking this video.